Good morning, Vananda. Today we are going to discuss about the sixth unit. Okay, the unit name is Power System Stability Analysis. Okay, what is meant by the power system stability? How we will be calculate that stability of the system? Okay, that all will be discussed in this unit. Okay, in this first topic is the classification of power system stability. How the classifications are done, or what is the main reason for classifications of that power system stability, that all will be discussed, and what is meant by the power system stability, the basic definition for that power system stability, that all will be discussed in the present class. Okay, first coming to the power system stability overview. Okay, first of all, a power system is defined as the network of one or more generating units, loads, and power transmission lines, including the associated equipments connected to it. Okay, power system means that it consists of generating units, distribution units, and also the transmission units. Therefore, the overall equipments are associated or connected to this system. Okay, therefore, the stability of a power system is its ability to develop to restoring the forces equal to or greater than the disturbing forces to maintain the system of equilibrium. Okay, to maintain that system equilibrium condition, therefore we maintain the stability of that power system. Okay, understand? Therefore, the power system stability problem get more difficult problem in the case of a interconnected large power networks. Okay, in the case of the interconnected large power network, the power system stability criteria is the major criteria or the major problem in the case of a large grid systems. Okay, therefore, what is the definition for that power system stability? Okay, a proposed definition for that power system stability. Okay, it is the ability of an electrical power system, okay, for a given initial operating conditions to regain a state of operation equilibrium, okay, after being subjected to a physical disturbances. Okay, if the physical disturbances are obtained in the system, therefore after the physical disturbances are obtained, then the system again regain to the equilibrium state. Okay, then that method is called as the stability. Okay, with most systems variables bounded so that particularly the entire system is remain intact. Okay, this is the basic definition for that power system stability. Okay, it is the ability of an electrical power system, okay, for a given initial operating conditions to regain a state of operating equilibrium after being subjected to the physical disturbances. Okay, after the physical disturbances are obtained in the system, then again the system will be come again back to the equilibrium position for that initial operating conditions. Okay, this operations is called, this system is called as the power system stability. Next, why the stability classifications are done in the case of the power systems means the stability analysis is easier. Also, it leads to the proper and effective understanding of different power system instabilities. When we are classifying that stability conditions, then we easily analyze the system stability, how the system will be there. Okay, how that system will be come to that equilibrium position. Okay, that all will be easily analyzed or understand then by obtaining the classifications of that stability. Okay, therefore the key factors that lead to instability can be easily identified. Therefore, We are identify the system is in the which stability condition. System, the power system is in the which type of stability that will be obtained, and how much time that will be taken for that the system will be come back to that equilibrium position. That all will be identified easily. Okay, therefore the methods can be devised for improving the power system stability. Okay, what are the various methods that will be considered for improving that system stability? That all will be easily understand for classifications of the stability of the power systems. Okay, next coming to the classifications of a stability. How the power system stabilities are classified. Okay, therefore the classifications is based on the following considerations. Okay, the classifications is based on that these conditions, that is physical nature of resulting instability. Therefore, how the system is physically there, that all will be observed, and the size of the disturbances considered, and what are the disturbances that will be obtained in the power system, and the process and the time span involved, that all will be considered for that classifications of this system. Okay, therefore the power system stability is basically classified into three types. Okay, therefore the power system stability is basically classified into three types. Okay, this is the first type of power system stability, that is the steady state stability condition, and second type is the transient stability condition, and third type is the dynamic stability condition. Okay, therefore based upon the physical nature of that system and size of the disturbances and the processing and the time, the power system stabilities are classified into three types. Based upon these following considerations are the following following considerations, the system will be classified three types. Okay, that is first one is the steady state stability, next one is the transient stability, next last one is the dynamic stability. Okay, this is the three classifications of the power system stability. By using these three classifications, how the system will be reached to the equilibrium position, that all will be easily obtained, and how the stability of the system will be improved, that all will be easily understood by the classifications of this power system stability. Okay, understand now? Next, what is meant by the steady state stability? Okay, what is meant by steady state stability? The ability to regain normal and stable operations after being subjected to gradual or slow changes in the load. If there is a gradually or the very slow changes in that load, in this condition, how the system will be stable, and what is the variations that will be obtained in the system. Okay, the type of variations are that the type of disturbances are called as the steady state stability. Okay, these steady state stabilities are obtained for gradual or slow changes in the loads. Okay, therefore concentrated with upper loading of the mission before losing the synchronism. Okay, before losing the synchronism, therefore how that loading of that system will be changed, that all will be observed in the case of a steady state stability. Okay, therefore the load is assumed to be applied at a rate which is slow. Okay, therefore the load for that system is, we are assuming that is very slow loads that will be increases or the decreases are in the changing position. Okay, that all will be observed in the case of a steady state stability. Okay, therefore the system is analyzed by the set of linear equations. Okay, therefore if the steady state stability is obtained in this case by using the linear equations, okay, by using the linear equations, we easily study that system. Therefore, action of voltage regulation and turbine governors are not be included. Okay, this is the steady state stabilities. Next, coming to the transient stability. Okay, this is the ability to regain normal and stable operations after being subjected to sudden and large changes in the load. Okay, if there is a sudden and the large changes in the load, in this case, the transients are to be obtained. That type of system is called as the type of stability are called as the transient stabilities. Okay, therefore, losses, generator excitation, transmission, switching operations, and the faults. Okay, therefore, by the transient stability that will be obtained means the loss of excitation for that generators and transmissions and switching operations and the faults that will be obtained. Okay, therefore, linearization of the system equations is not permitted. Okay, in the case of a transient stability, the linear systems equations does not to be permitted and studied on the basis of the swing equations. Okay, therefore, the steady state stability will be understood by using the linear equations, but the transient stability that will be understood by using the only swing equations. Okay, therefore, the action of voltage regulators and the turbine governors are not included. Therefore, the action of voltage regulations and the turbine governors are not included in the case of a transient stabilities. Okay, next type of method is the dynamic stability. Okay, next method is the dynamic stability, same as a steady state stability. Okay, therefore, the dynamic stability is same as the steady state stability. In this case, included action of turbine governors and also the voltage regulators. Okay, in this case, includes the turbine governors and the voltage regulators. Okay, the study time is that is 10 to 4 to 10 seconds. Okay, the study time for the dynamic stability is 4 to 10 seconds. Okay, these are the basic types of classifications in the case of a power system stabilities. Okay, that is the steady state stability, transient stability, and the dynamic stabilities. Next, the power system stability classifications. Next classifications are the rotor angle stability, voltage stability, and frequency stability. Okay, first coming to the rotor angle stability, a small disturbance angle stability. Okay, this is called as the very small disturbance angle stability. Therefore, it is called as the transient stabilities. Okay, therefore, voltage stability means the small disturbance voltage stabilities, that is large disturbance voltage stabilities. Okay, these voltage stabilities are again classified into small disturbance and large disturbance voltage stabilities. Next, coming to the frequency stabilities, that is the short-term frequency and the long-term frequency stabilities. Okay, these are the various classifications are there in the case of a power system stability analysis. That is, the rotor angle stability are again classified into two types. Small disturbance angle stability. Next one is the transient stability. And voltage stability is again classified into small disturbance voltage stability and large disturbance voltage stability. And the frequency stabilities is also classified as short-term frequency stability and the long-term frequency stability. Okay, these are the various classifications are there in the case of a power system stability. Okay, therefore these classifications are observed like this. This is the power system stability. First consideration is the rotor angle, frequency stability, and voltage stability. Okay, that rotor angle stability is classified into small disturbance transient stabilities. Okay, this is called as the short term stability. Okay, this will be obtained very short term, that is the small disturbance angle stability and transient stabilities are obtained in the short term. Okay, therefore, voltage stabilities are the short term and also the long term. Okay, that is the large disturbance voltage stability and small disturbance voltage stabilities. Okay, the frequency stabilities is also short term and the long term stabilities. Okay, these are the various classifications that will be obtained in the case of a stabilities. Next, first one, in that first one is the rotor angle stability. Okay, what is meant by the rotor angle stability? Okay, it is referred to the ability of a synchronous mission of an interconnected power system to remain in the synchronism after being subjected to a disturbances. Okay, if any disturbances are obtained in the synchronous system, then the synchronous mission is remaining the synchronism. Okay, this type of stability is called as the rotor angle stability. Okay, therefore the rotor angle instability occurs due to the angular swings of some generators. Okay, therefore the rotor angle instabilities that will be occur during the some swings that will be obtained in the generators, their loads, and the loss of that synchronism with other generators. Okay, for that reason, therefore the rotor angle instabilities are obtained. For that loss of synchronism, or there is an angular swings between the angular swings that will be obtained in the case of a generators. Okay, therefore the rotor angle instabilities are to be obtained. Okay, depends on the ability to the mission or restore equilibrium between the electromagnetic torque and mechanical torque of each synchronous missions. Okay, and also the rotor angle stability will be depending upon the angle between or restoring the equilibrium angle between the electromagnetic torque and the mechanical torques. Electromagnetic torque and the mechanical torques of a synchronous missions. Okay, therefore, at equilibrium, input mechanical torques are equal to the output mechanical torques. Okay, what is meant by the equilibrium condition means the input mechanical torque is equal to the output mechanical torques of the generator. Okay, in the case of any disturbances, the above equalities does not hold leading. Okay, understand me? Next, what are the classifications are there in the case of a rotor angle stabilities? That is the small disturbance rotor angle stability and large disturbances rotor angle stabilities. Okay, coming to the small disturbances rotor angle stability. Okay, this is the ability of a power system to maintain the synchronism under the small disturbances. Therefore the system will be maintain that synchronisms. Okay, therefore the disturbances are considered to be sufficiently small such that the linearization of the system equations is permissible for the purpose of analysis. Okay, therefore the disturbances are very small, therefore the linearization of the systems are very easily. Okay, at the time frame of interest in the small disturbance stability studies, okay, is of the order of 10 to 20 seconds. Okay, therefore these small disturbances are obtained about 10 to 20 seconds. Okay, next, coming to the large disturbances. Okay, it is the ability of a power system to maintain the synchronism under the severe disturbances. Okay, if the severe disturbances are obtained, in this case, the system will be maintain the synchronism. Okay, such a short circuit on a transmission lines. Okay, this type of disturbances are called as the large disturbances. Okay, therefore large disturbance rotor angle stability. Okay, these disturbances are large so that the linearization of system equations is not permissible for the analysis purpose. Okay, in this case, we are using the swing equations. Okay, therefore, the time frame for interest for a small disturbance stabilities are in the order of 3 to 5 seconds. Okay, understand. Next, voltage stability. Okay, what is meant by the voltage stability? It is the ability of a power system to maintain the steady state voltage at all the buses of a system after being subjected to the disturbances for a given initial operating conditions. Okay, for a given initial operating conditions, how the system voltage that will be stable, that all will be observed by using this voltage stability system. Okay, therefore a system is voltage unstable. Okay, therefore the voltages are in the unstable conditions. One bus in the at least one bus in the system. Therefore the voltage magnitudes are decreases as the reactive power injected increased. Okay, therefore if any one of the bus, okay, if any one of the bus there is a instability in the voltages, therefore the magnitudes of that voltages will be decreases as the reactive power inject is increases, as the reactive power inject is increases. Therefore the voltage instability results in a very fall or rise in the voltages of the some buses. Okay, therefore the voltage instabilities are obtained. Therefore there is a small rises or the changes and the voltages. Therefore, large-scale effects of the voltage instabilities. The driving forces of voltage instabilities is usually the loads. Okay. Therefore, depending upon that loads, the voltage instabilities will be obtained. Okay. Therefore, the voltage stability problems is also experienced at the terminals of the HVDC links are connected to the AC systems. Okay, when the HVDC links are connected to that AC systems, therefore the voltage stability problems is also affected. Next one is the voltage stability classifications. Okay, therefore small disturbance voltage stability and also the large disturbances voltage stabilities. Okay, the small disturbances voltage stabilities refer to system ability to maintain the steady voltages. For the small disturbances, therefore the system will be maintained in the steady state stability. Therefore, there is incremental change in the loads. Okay, a combination of your both linear and non-linear techniques are used for that analyze purpose. Okay, next coming to the large disturbance voltage stabilities. Okay, due to that large disturbances that will be obtained in that systems, therefore the system will be in the steady state stability. Okay, it is called as the ability to maintain a steady state voltages for the large disturbances. Okay, such as faults, loss of generation or the circuit discontinuities. Due to that, the large disturbance voltage stabilities that will be obtained in the system. Okay, therefore the study period of interest may be extended for a few seconds. Therefore the steady state period will be extended for a very few seconds. Okay, next last type of stability is the frequency stability. Okay, therefore it is the ability of a power system to maintain the steady state frequency for a severe system upset resulting in significant imbalances between the generators and the loads. If any imbalances are obtained between the generators and the loads, in this case the frequency stabilities will be obtained. Therefore the frequency instability leads to trip the generator units and the loads. Okay, therefore the disconnecting that generators and the various loads for that frequency instabilities. Therefore the frequency stability may be short-term phenomena or the long-term phenomena. Therefore the rotor angle stability and the voltage stability comparison. How we will be compare that rotor angle and the voltage stabilities? Okay, therefore the rotor angle stability is basically a generator stability, while the voltage stability is the load stability. Rotor angle stability means the generator stability and voltage stability is the load stability. Okay, therefore the rotor angle stability is interlinked to the power transfers, where the voltage stability is related to the reactive power transfers. Okay, this is the real power transfers and these are the reactive power transfers. The rotor angle stability is the real power transfers and voltage stability is the reactive power transfers. Okay, these are the some basic differences between the rotor angle stability and the voltage stabilities. Okay, these are the various classifications for that power system stability, that is rotor angle stability, frequency stabilities and voltage stabilities. Okay, mainly the power system stabilities are classified into three types, that is steady state stability, transient stabilities and dynamic stabilities. Okay, therefore why that power system will be stabilities will be classified means, for easily analyzing the power system stabilities, then for we are classifying the three types of your stability systems, that is steady state, transient and the dynamic stabilities. Okay, this will be classified depending upon the physical natures and resulting instabilities and the size of the disturbances and the process and the time spans. Okay, these are the following considerations. For following these considerations, the system will be classified like this. Okay, understand ma? These are the various classifications for the power system stabilities. Okay, thank you. We continue in the next class.